Well, today we begin our earnest lesson in fractal field mechanics. This is where it all began. My name is Rod Craig, and this is what I work on. It might just seem like a triangle, but it's much more than that. It's a lot more than that. In a minute, I'm going to show you some basics that scale down from, we've gone from this giant thing over here, which is 9 feet high, 9 feet tall, to these smaller ones that are made out of magnets, inch-and-a-half magnets. They're not that big. You might remember this one. It scales to the one behind it. Same thing, just smaller. That's a scalable thing called Qualian geometry, or ratio-dependent scalability. Scale invariant geometry. Fractal scale invariant geometry. Negative space fractal scale invariant geometry. Oh yeah, you might recall this little beauty from yesterday, the Pentagon. This is all magnets. It's 134 magnets. Same triangles, same designs. This one sits on a triangular base that is only 4 triangles right there. So in an urban setting, if these were 15 feet, these triangles, this would be a 30-foot by 30-foot base that would rise 90 feet into the air. Beautiful. Self-supporting, self-connecting, self-limiting isomorphic design. This, my friends, is a quantahedron. Notice the pentagonal symmetry of this one. This is made out of magnetic buckyballs. This thing is made out of hundreds and hundreds. There's a triangle. You can start to see that there are geometries in here that are obvious. What I do is I take these things, and when you see these little circles, those are insets that I put in there myself as receptors on cell sites. Because this is literally a cell membrane now. It's completely hollow. This is one layer of magnets thick, completely hollow. And based on the same geometry as, guess what? That's right. This thing is what came before the little triangles, which came before the big triangles, which came before the even bigger triangles. There's another set that have 54-inch faces, 55.5-inch faces. Think about that. 55-inch face triangles that go 2 stories out of 72 triangles. I've done it many times. This is the basis of all dodecahedrons in nature. This is based on some very different bonding patterns. This is a strong pattern. This is like a nuclear pattern. This is ionic. And then underneath is a valence pattern. This is a 60-degree bond. This is a 90-degree bond. So these things can come apart. Oops. So these things can come apart and go back together. In this case, forming a dodecahedron. Or in this case, a partial dodecahedron. All of those quantahedra behind me are made out of this stuff. This plus a hexagon gives you a flat surface between them. So when you see flat planes, that's a hexagonal bond. And when you see any kind of a corner in microscopic architecture, which is always going to be spherical, the only bonding pattern you're going to see in a hyperbolic structure is going to be a pentagonal structure. Anything else is too acute. Those are for energy and for structures that are less than dynamic. Those are for static structures. We'll get into that later. The tetrahedron versus the cube versus the dodecahedron. Those are all the primary basic geometric constants of, guess what? Human perception. In a nutshell, you can think of me as the Willie Nelson of geometry. Mnemogenics states very plainly that everything you see around me is memory. This guy right here, that's the memory of volcanoes. Everything around me is the memory of volcanic ash that came from huge eruptions that covered this place with hundreds and hundreds of feet of ash, and on top of that is more volcanic lava with more ash and more volcanic lava. All these trees are the memory encoded in the DNA of this specific kind of tree. All of these sagebrushes contain the memory of sagebrush. You ask, where's the memory of the universe? Well, that's in the universe. The memory of empty space is what we humans perceive as the part that happens between me and that sculpture and that sculpture and that sculpture. We call it empty space, but perception only sees frames, simple, one at a time frames. And what we call time is just a frame rate. Mnemogenics says that we're breathing the memory of air. We're breathing the memory of the very thing, oxygen and nitrogen, that fuels the memory of everything else. It's memory too. We're walking on the memory of the past. We're walking on the solid memory of the past, because memory comes in a cycle. It starts as pure memory, which is imperceivable to us. We only perceive a very narrow slice of the EM spectrum, period. Out of a huge, gigantic, enormous possible potential, we experience a very tiny, limited slice that is governed by, guess what? Geometry. Before you start laughing too hard, ask yourself a question. Remove geometry from the equation, just geometry alone. What remains of what we perceive of as physical reality?